Hello and welcome to Lesson 7, Part B in the Online Terrestrial Navigation course. This lesson is Azimuth Part 2. This is a continuation of the previous 3 lessons. You'll need your answers from Lesson 7A for this exercise. If you don't have them, you'll have to do all those calculations over again, but it doesn't hurt to practice. So if you want to do them over again, just do them over. So let's jump right in. Here you'll notice this is the same question as question 1 in lesson 7a, except we have this one little part added onto the end right here. What is the deviation of the standard magnetic compass? This will be what your questions look like on your Coast Guard exam. All this information that we've dug through and sorted out in the previous 3 lessons, it's all going to boil down to a TVMDC problem. So if you have all this information from the previous lessons, let's take a look at what we're going to do with it now. This equation right here is what we're going to be using to solve this problem. And I know it looks like a big scary math problem, but if you can remember which 10 numbers to push on your telephone to talk to your mother, then you can remember which 10 numbers to push on the calculator to get the right answer to this problem. Um, you probably will memorize this formula before it's over with, but I've put a link to this PDF in the description of the video. When you go in the exam room, there will be a Bowditch Volume 2, Pub 9 Volume 2, as part of the resource material in there, reference material. Page 505 is where this equation is found, and this is the equation here that we'll be using, equation 4a. And when we finish the equation, if it comes out to be a negative number, you'll simply add 180 degrees to it. And then you'll follow this little rule right here to convert it from Z to Zn. And it'll make more sense to you as we get further along in the lesson. But if you want to download this PDF and use it as a reference material for these problems, go ahead and do that because it will be available in the exam room. All you got to remember is that it's page 505 in Pub 9 Volume 2. So again, we're using the Texas Instrument 30XA. And here's where it gets a little important that we're all using the same calculator on this. There's only certain calculators allowed in the exam room. This 30XA is one of the ones allowed in the exam room. Um, and so the first thing we're going to do, you have these 3 numbers from lesson 6B, and we're going to store these numbers in the memory of the calculator, and this is how we do it. So we're going to store the latitude as number 1, and it's 24.2. We'll key in 24.2, and it's a positive number, so we just hit store 1, and you'll see the little M1 come up in the display there. We can clear that. Declination is 4.2.2, and we'll hit this little funny looking key right here, which will turn it into a negative. And we'll hit store 2. You can clear that, and then 293.9 for your local hour angle, 0.9, and then hit the funny looking little button right here to make that a negative, and store 3. Now if you just hit your recall button, recall 1, recall 2, recall 3, it's pretty important that you store it. If it's a negative number, make sure you store it as a negative number in the calculator. And then we'll take this equation. We know these are stored in the calculator as 1, 2, and 3, so we'll just replace latitude, declination, and local hour angle in the equation with a 1, 2, and 3. So local hour angle, it becomes 3. And and the latitude is going to become 1, and your declination is going to become 2. And these are going to be the buttons that you push on your calculator to get the correct answer. I know it looks like a lot, but trust me, you'll remember it uh, eventually. And one of the things that you can't really see with this simulator calculator here that you'll notice on your calculator, when you start keying in this equation, let's see if I can get it here. We're going to hit recall 3 sine. Now on your calculator, there will be a little blink on your screen. It's because that's a pretty big calculation for the calculator. It takes it a second to do it. You believe it or not, you will eventually start keying this equation in faster than what your calculator can take it. So anytime you hit sine, cosine, or tangent on your calculator, just give the calculator just a second to calculate it before you keep keying in numbers, or else it'll get it all jacked up before you get to the end. So let's start this over again. We'll hit recall 3 sine, recall 3 sine, divided by, and we're going to start our parentheses because there's parentheses right here. We'll say recall 1 cosine times recall 2 tangent minus recall 1 sine times recall 3 cosine, close your parentheses, then equals second tangent. When we come up with a negative number, remember on the Bowditch page it says if you come up with a negative number to add 180 degrees to it. So let's add 180 degrees to that negative 75 plus 180. So Z equals 104.3. That's an important number right there. You may want to jot that down. So let's back out of here. Remember that 104.3. And this little part right here is at the bottom of that Bowditch page. So you use that. We are in northern latitude with a local hour angle greater than 180 degrees. So Zn equals Z this time. So 104.3 is going to be what we put in as true on our TVMDC problem. We have a variation of 7 degrees west, which gives us a magnetic of 111.3, and the sun is bearing 105.5 per standard compass. That'll give us a deviation of 5.8 degrees east. And that is a complete workdown of an azimuth of the sun problem. All right, well, work through these next 10 problems. Then I'll post another exercise that will be just the full azimuth problems without the breakdown that we did for lessons 6A, 6B, 7A, 7B, because when you get these questions on your exam, this is what they are right here, and you'll have to be able to go through and work each one of those steps out to come up with this answer. This 5.8 east is your final answer on the azimuth problem. So just grab that worksheet, do the work downs on it, and the next lesson will be a lesson, a worksheet with different azimuth problems on it. All right, well, thanks for watching.